Hi, all my lovely advanced math students, all 6 or 10 of you guys. Hopefully you guys picked up a note packet. I'm sorry I'm not here. Was expecting to be here today, but my daughter had a medical emergency, so I'm not here. So you hopefully picked up a note packet and a worksheet packet. Okay? We are doing, for the next 3 weeks, a unit 3. Very, very short. If you look at the notebook packet, there are 4 sections that we are doing, if you guys are looking at it. 4 worksheets, 1 review, 1 quiz in there. You know, super chill, okay? And we'll decide. We can either take the test for this unit, and it's just a test, not a final, either finals week, or if you want to take it the Thursday before that and have finals week off, could be done too, whatever you do. So we are going to start today because I thought, might as well start. Okay, so you hopefully picked up a packet, like I said, and you picked up worksheets. Okay, so I am planning for you guys to turn in worksheets like one at a time and rip them off. I'm going to grab a worksheet packet real quick. And in the worksheet packet, okay, you are going to see some questions. It says objective 1 through 4. It does have the review in here. And they're just ones that we are going to try to do. And it's review of factoring, things that you really kind of need to know better when you get to college math. Now, if you're taking AP Stats, not as much, but SATs, things like that, you're going to be needing to know this. Taking some type of calculus or pre-calc in college, you need to know this. So we're going to just talk about it. And we're not going to use so much of an area model. We will sometimes, but we are just going to factor. So the first thing we're just going to review is difference of 2 squares. The difference of 2 squares, we've done it so much this year, but just to kind of review, both your terms are squared, something squared, 36, 49, things like that, m squared, m to the 4th, anytime even powers. And we always take the square root of both those numbers, one's plus and one's minus, so that the middle terms cancel out if you did an area model. So if you're looking at number 1, you can just think in your head, what's the square root of both of those? And the square root of 36 is 6, and the square root of 49 is 7, but the square root of m squared is m. So it should be 6 minus 7m, and it doesn't matter which one you put first, but one has to be positive and one has to be negative. You can always check it by an area model, but I'm hoping that you guys are going to feel easy with it, that you can do it without an area model. Same thing on number 2. You're basically taking the square root of both. Square root of 16 is 4. The square root of m to the 4th is m squared. So it'd be 4m squared minus m squared, 4 plus m squared. Okay, now, this is a difference of 2 squares. It's kind of weird. This is a number squared, and this is a number squared. Okay, has a minus in between. It's difference of 2 squared. So the square root of a plus b squared is a plus b. The square root of x plus y is x plus y, because it's squared. So you're basically taking the square root. So the square root of a plus b squared is a plus b, and the same thing on that. So we're going to do 1 plus and 1 minus. We're going to have to be very careful with the minus. Don't have to be careful with the plus, but we have to be careful with the minus and distribute. So our answer would be a plus b minus x minus y, and a plus b plus x plus y. Okay. Now, you're going to see trinomials, you're going to see things that are backwards. Okay? My suggestion is not to move it so it's x squared in the front, just because of the negatives. Okay? So it doesn't matter. If you want, you can do an area model. It is totally up to you. I need to multiply to be 10, add to be negative 3x, but I need a negative x squared. So maybe one of these has to be negative and one has to be positive, which I don't like to do, but that's what's going to be the case. And 5 and 2 are going to give me 10, but I want to make sure that when I do this, I'm going to have, I don't know why I put the x there. That's x, sorry, put the x there. I want to make sure that I'm going to get a negative 3. So I know these are 5 and 2, okay? So let's just say this is 5 and this is 2, okay? 5 times 2 is 10. 2 times x, 2x. 5 times negative x, negative 5x. Hey, that will give me negative 3. So 2 minus x, 5 plus x. It's okay if it's backwards. Okay? Doesn't matter if it's fourth power or anything like that, as long as it is a trinomial of the squares. You can do an area model, or you can skip the area model and maybe no. This is 9a to the fourth plus 4. That's a multiple of 36a to the fourth. I need to add to be negative 13a squared. I would need negative 9a squared and negative 4a squared. Okay, so here would be 9a squared. Here would be negative 4a squared. Or sorry, no, my bad. Just positive a squared, sorry. This would be minus 1, and this would be minus 4. So I'm hoping that you notice both of those are a difference of 2 squares. So a squared minus 1 would be a plus 1, a minus 1. 9a squared minus 4 would be 3a minus 2, 3a plus 2. Okay, last one. This one should be easy. Hopefully you recognize this is a plus b times a plus b, or a plus b squared. We've done a lot with the, if you guys remember the x plus h, what ended up to be like that. Okay, 4 terms. We've done it, but I just want to make sure you guys are good with it. But before we do the 4 terms and do it in all boxes, I want you to see there's a GCF here, and it makes it so much easier if you take out the GCF now. I look at all these, they are all divisible by 4. So I'm going to take a 4 out of all of them. Okay. Now I'm going to do an area model. I have all 4 of these I'm going to put in boxes. Because it's 4 terms, we have 4 boxes, we can put them all in. This has a common factor of d. This has a c. 2d times d would be d squared. Negative 2f times c would be negative 2cf, and we double check that. So our answer would be 4c plus 2d, d minus 2f. If you forgot to take out a GCF and did this, you can always do at the end, because that happens a lot. But just make sure when you're done, none of your parentheses have a GCF. Okay, so if you look at the next one, none of these have any common factors. So I'm going to do straight area model. Doesn't matter where you put the boxes, they're always going to have a GCF that you can fool with and get. And if they don't, we'll talk about that. These have a common factor. Oops, they don't have a common factor. So that's bad. So I do need to rearrange this because no common factors are here. Okay, that could happen to you. So let's try it this way. So I'm going to switch these two. And hopefully now I have a common factor. Oh, I have a common factor of b here. This has to be 3a. This has to multiply by negative c. Whoops, still not going to work on me. Oh my gosh, I just messed this whole problem up. Okay, I just messed this up twice. How did I mess it up twice? Did I write it wrong? So there's not a common factor this way, or nothing's going to multiply by 3 to give me 4 there. So let's switch these. Let's make this negative 12 AD. This doesn't happen very often. And make this 4 CD and see if that will work. Now, 3 goes into 12, negative 4. I need a D. And then let's make sure that works. Oh, it does. So there, every once in a while, we've never done these in class, you may have to move things around in your boxes so that it can work out. And now it did. So I had to fool with this twice before I could get it in the right spots. And my apologies, I'm sorry, it was way over there. So again, I had to try different combinations and put it in different boxes so that I could get a GCF and get it to multiply. So I had to flip these two. Sorry you couldn't see that. Okay, so again, I had to put the 12 here because 3a went into 12 AD. If I put the 4 here, it didn't work out. Okay? Sorry that you couldn't see that. Okay, let's go to SOAP. Same opposite always positive cube problems. So there are something called difference of two cubes and sum of two cubes. I'm going to do it by area model, but I also have, this is your little algorithm you can follow. It is always cubed. So you take the cube, like we took up here, the square root to do these. We're going to take the cube root to get the first parentheses. But then the second parentheses follows that pattern. And if it's plus here when you take the cube root. If it's minus here when you take the cube root. And then SOAP stands for same as the problem, opposite of the problem, and always positive. Same as the problem, opposite of the problem, always positive. So you can also do it by area model. I'll show you an area model really quick. You have choices. You're going to put the largest term here and the last term there, or first term there, last term here. You take the cube root of each one. So the cube root of a cubed is a. The cube root of b to the 6th is b squared. And because it's a minus, you put a minus there. And then you fill in what you can. A times a squared gives you a to the cubed. And look at how that is x. That was x squared. This is a. That's a squared. That would give you a negative a squared b squared here. Now, because everything cancels out, this has to be the opposite of that. And that's where the SOAP opposite comes. So this has to be positive a squared b squared, which makes this a b squared. So that middle term is basically these two terms multiplied together. So these two multiplied together is a b squared. This last term, I know if this multiplied together, negative b squared times that would be a negative a b to the 4th. Then this has to be positive a b to the 4th to make 0. I would mean that I need b the 4th there. And b the 4th times b the squared is negative b the 6th. So my answer would be a b squared plus a b squared plus b to the 4th. Again, it's called SOAP. Same as the problem, but these are cube roots. Opposite of the problem. This is square root of that. This middle term is those two multiplied together. Always positive. That's that number squared. So I'm going to do this one without an area model. I'm going to take the cube root of each one of these. So the cube root of 8 cubed, or 8x cubed, is 2x. The cube root of 27 is 3y. Then I have to do this. So we're going to take that first term and square it. That'd be 4x squared. Opposite, you multiply those together, 6xy. And the last term is the last part squared, 9y squared. If you're not sure, you can always check it by an area model. Oh my God, I'm sorry. Again, I can't see that. So, cube root of these. This first one is that squared. Middle one is these two multiplied together. Last one is the last number squared. Okay, last thing. More difficult factoring. I want you to see this is a trinomial. This is the same as saying z squared minus 3z plus 2. If you can factor that, you can factor that other one. So we're letting z represent x plus y. Okay? If I was factoring this, it would be z minus 2, z minus 1. I'm going to replace where the z was, x plus y. So the answer would be x plus y minus 2, x plus y minus 1. This one would be the same as z squared plus 10z plus 16, where I'm letting z equal that whole thing right there. I know that two numbers that multiply to be 16 add to be 10 are 8 and 2. So this would be z plus 8, z plus 2. So we would write this as, replace that with z. So x squared minus 3x minus 6 plus 8. And x squared minus 3x minus 6 plus 2. And then we want to add like terms. So simplified, this would be x squared minus 3x plus 2. And this would be x squared minus 3x minus 4. Okay? I know that's a lot right now. It's just a review of some factoring stuff. If you look at the worksheet, okay, it has some easy ones, just a little hint. And again, if we need to take more time, we will take 2 days on this. But the first ones, just so you guys understand, difference of two squares. Be careful on number 2, there's a GCF. Also on number 3, there's a GCF. Number 4 is a difference of two squares. Then these are trinomials. Some of them are backwards, like number 7. Some are the 4th power. Okay, some are backwards, like number 11. These are 4 terms. This will be interesting how you guys do this one. We may do this on Tuesday. But that is 6 terms. It's going to be interesting how you guys try this one. So we're going to start that one and kind of see how it goes. And then on the back, more 4 terms. Cube problems, cube problems, cube problems, cube problems. And then these 2 are like the last one. So this is like number 11, and this is like number 12. Okay? Again, I don't want you to have to do any homework. I want you to be able to do this in class. If it takes us 2 days to do a lesson, not a big deal. I want you guys to be able to take your time and do these. Okay? I'll see you guys tomorrow. Thank you for listening to all that. Hope you have a great day.